So our next speaker is Sergey Nazarov. I think everybody should know who that is. He's the co-founder of Chainlink, and today he's talking about Chainlink 2.0, hybrid smart contracts and off-chain computation.
Hi, Surya. Good to see you. Good to see everyone. So yeah, I'll be talking about our Chainlink 2.0 white paper, where we walk through a few key concepts about how decentralized Oracle networks are going to be evolving from here, how they're going to be built, and what some of the key nuances are around making decentralized Oracle networks into services, decentralized services that people find useful for building more advanced smart contracts. So the first conception that we have in the paper that I think is very meaningful is that of a hybrid smart contract. So a hybrid smart contract is basically redefining what we consider to be a smart contract. Before, we might have considered a smart contract to be one contract about tokenization, and then might have moved on to being about one contract about tokenization and another about DAO voting and another one about multi-sig security, another one about something else. What we're basically saying is that the more advanced smart contracts are actually a composition of both on-chain code in running in a blockchain or even multiple blockchains, and off-chain trust minimized code running in a decentralized Oracle network. A decentralized Oracle network is basically a committee of nodes that comes to consensus about various computations, but does not have a blockchain, right? It does not generate a blockchain. It simply generates consensus about certain key inputs or computations that don't need a blockchain, but do need to be given to a blockchain in order for a smart contract to do something useful. Generally speaking, the way this architecture is evolving is once again, just like initially maybe the entire conception of a smart contract might have been one smart contract, and then it moved on to two smart contracts interacting with each other, maybe about tokenization and voting. And then DeFi expanded it to those two contracts relying on a data feed about off-chain data. Now what we're seeing is both an expansion in the amount of contracts on chain as individual services that need to interoperate with each other to be composed into more and more advanced applications, and a greater amount of off-chain services, whether that's the provision of data, whether that's the provision of computation, or whether that's the provision of random numbers, cross-chain, any number of other key services. Basically, these off-chain services are equivalent to all of the APIs and web services that developers use to build their applications in the web world, whereas the smart contract code can be considered the application code that's internal to the web application, and then the blockchain can be considered a distributed system environment for computation or decentralized storage mechanism, or whatever version you want to label it as. In any case, this is the more advanced version of smart contracts and hybrid smart contracts that our entire industry is already going towards. We know because we have multiple decentralized applications, smart contracts, that are all consuming multiple services. So we have smart contracts right now that are users of Chainlink networks that consume multiple data sources from multiple distinct DONs. So a DON is a decentralized Oracle network, and each one generates its own distinct service. We also have them consuming off-chain computation from something called keepers. So those are separate, distinct networks. Actually, each of those networks is generated for each distinct contract for its unique computation that they need performed. And then you have random number generation that is also consumed. So we are already seeing the composition of multiple pieces of on-chain code with multiple pieces of trust minimized off-chain code and data. And this is the more advanced version of where everything is going. Where this likely ends up is what we call in the paper a decentralized metalayer. So a decentralized metalayer is really kind of the conception that you can make a DApp in both of these layers, basically. The decentralized metalayer being the off-chain compute, off-chain data, off-chain decentralized Oracle network environment. And the second environment is smart contracts on blockchains. And I think where we're going to arrive is that people actually write hybrid smart contracts in their most advanced form as a multitude of these services, on-chain services plus off-chain services. And eventually that'll become simple enough through some kind of domain-specific language or some kind of compiler that just generates all the services or generates the necessary connections to the on-chain code that was made as part of that smart contract. And so this is where we believe we're going. And this is what we're working on in the medium to long term in terms of what we call the decentralized metalayer, which is this abstraction layer between blockchains and everything else. Data, trust minimized off-chain compute that doesn't need to be done on a blockchain. And I want to be very clear that we are still saying that we want on-chain computation and on-chain state and on-chain value transfer and on-chain multi-sig and all those great things, because that is what's being enabled by these services, right? Just like you want core application code in web services that then uses various other services, APIs, Twilio, or Google Maps, or Stripe for payment or something, you still need the core code. And the core code will continue to be on blockchains in the form of smart contracts because it'll be hyper transparent, it'll be hyper accessible, and it'll be very easy to put money into, because that's what a lot of blockchains have now become, is these kind of value holding, globally accessible ledgers, right? Where people want to put contracts in those environments because there's a lot of value that can flow into the contract. And so that value will still flow into smart contract code on blockchains, but that on-chain code will be super powered by trust minimized off-chain data, trust minimized off-chain randomness, trust minimized off-chain compute, trust minimized off-chain cross-chain movements and other things. And so all of those additional services are what's keeping our industry doing what it's doing today. And the appearance of more of them will allow our industry and what gets built in this ecosystem generally to go to what's possible, and to really actually build the applications that start to define our industry over the long term, in my opinion. Now, it's also useful to view an Oracle network in terms of where it is on this spectrum. So this is the spectrum I tend to look at it on. One dimension is feature richness, and the other one is trust minimization. So feature richness is scalability, how many integrated services there are, various scalability, performance aspects, some privacy aspects, basically feature richness. And then the other one is trust minimization. So centralized web servers are very, very feature rich, but they're not trust minimized, right? They're completely controlled by Robinhood. They're completely controlled by a bank. They're completely controlled by whoever. And that has fundamental failings in that people don't want that level of control to be in the hands of a third party. They want a decentralized method for transacting, because that's fairer, more transparent, and eliminates counterparty risk, and also creates better yield due to the efficiencies it generates. In any case, Oracle, and on the other side of the spectrum, you have blockchains. So blockchains are highly, highly trustworthy. They are very focused on a singular type of transaction, which is the packaging of transactions into blocks. They have relatively limited functionality as far as, they can't reach out to data sources. They can't do certain types of computations, that type of thing. Oracle networks are in the middle, and they are actually seeking to supercharge blockchains so that eventually you can have the hybrid applications, hybrid smart contracts that approach and are at parity or are even superior in their performance or other properties to centralized web system applications. Once again, that's what this looks like. That's what all this is about. That's the body of work we work on. That's the body of work we do research for. It's how do we compose highly performant, advanced hybrid smart contracts through combining various on-chain code with various off-chain trust minimized computation, data delivery, and so on. The goal of the paper and the goal of our body of work now is to just provide more of these services, solving various critical problems along the way. So those problems can be the privacy of data, right? There's certain data that can't go on chain unless it can be made private, such as certain identity data. For these types of problems, we are working quite actively on something called DECO and other approaches to obfuscate the details of a piece of data, but still give people the ability to have proof that the data is in a certain state. Likewise, there are other research problems around consensus. There are research problems around fair sequencing. All of these are services, right? So these are just more and more services that generate the ability to make more and more advanced hybrid smart contracts, which continually advances what our industry is about, because developers are now able to build hybrid smart contracts with identity data. They're able to build fairly sequenced DeFi applications. They're able to build things that have off-chain compute capabilities through keepers, that would have previously been run in a central server and would have broken the trust assumptions of the decentralized application, right? So the fundamental body of work here is not making more blockchains. It's not making more centralized web systems. It's creating a kind of middle ground that doesn't do what blockchains do and seeks to do what centralized web systems do in a trust minimized way in order to supercharge the core code of a smart contract that's on a blockchain. We already see this happening in DeFi. If you look at the DeFi landscape, you will basically see a multitude of services and you will see a multitude of contracts using each other, right? So you will see different lending contracts, derivatives contracts, various other contracts using each other as a service, right? So they don't have to build every single thing. They can use each other as a service. That's very powerful. And then you have various off-chain services that all of these systems need in order to become operational, maintain their end-to-end security, remain decentralized, have high uptime guarantees. For example, the Chainlink networks during the recent gas spikes to 2,500 gas maintain performance completely as expected, while other systems weren't able to, didn't stay up, didn't broadcast transactions, didn't allow users to close positions, didn't work basically. So fundamentally, an Oracle network, a decentralized Oracle network, should provide an ability to generate more advanced hybrid smart contracts. It should provide decentralization and security to the application that's greater than if the application developer ran their own service, and that's a big challenge. And then it should also provide highly reliable systems and uptime guarantees that can overcome things like reorgs, can overcome things like the improper collection of gas congestion issues that can all come together at exactly the wrong moment. And so far, the Chainlink network and the decentralized Oracle networks in the Chainlink format have been able to do that, right? And so we continue to provide all of these services. There's a continual stream of very complicated problems that go into continually providing both the security, the uptime, and actually scaling of that security and uptime for more and more value secured in these smart contracts. So that's another area of research that we're very, very heavily spending time on and is very important. We have a lot of exciting stuff there in terms of efficiency and how you can efficiently actually aggregate signatures from hundreds of nodes, eventually thousands of nodes, and how you can achieve levels of sub-second speeds for data delivery and other things that should match and even surpass some of the fastest blockchains out there while maintaining security of the decentralized Oracle network and the service it provides. What this all leads to, in my opinion, really simply, like the body of work that we're all involved in, we are involved in moving the world from a probabilistic kind of trust-based, brand-based world, right, where people give promises that don't need to be really honored too much, right, because they're on paper and there's legal system and like maybe it's honored, maybe it's not honored, to a cryptographic truth-based world. And we're actually driving towards a world where all of the world's value and all of the world's systems are interoperable in an open, transparent way, because that transparency is forced through cryptographic truth and decentralized systems, right? So what you see at the end of the day is the interaction between derivatives and insurance protocols and capital markets protocols already in the DeFi world. But I personally think that the entire world's value across the derivatives industry, capital markets, insurance, carbon credits, real estate, equities, all of these things will eventually be in a set of different chains that all interoperate with each other and that properly interface through the use of these decentralized Oracle networks, both with each other across chains and with other external systems. And so that is the body of work that we're involved in, of solving the difficult research problems and then productizing those research problems into real world solutions that accelerate the blockchain industry and the smart contract industry into doing much more. Our fundamental goal is to become a global standard, much like HTTPS or Linux. Our goal is to become the global standard for how hybrid smart contracts operate across chains, across data, across trust minimized off-chain computation, while still remaining on-chain as the core code of the smart contract. We do this by solving various critical research problems in various categories, right? So the first category that we're kind of well known for is providing market price and market data for anywhere from 60 to 80% of DeFi that needs oracles, depending on the day. And so that is quite a large achievement, because we're able to consistently provide the highest quality data at sub-second speeds, only limited by the speeds of the blockchains that we're putting the data on, right? And so that involves solving its own set of problems about off-chain data aggregation, validation, scoring nodes for data delivery, scoring data providers for data quality, being able to programmatically add and remove data sources that are properly performing or not properly performing. So that's some measure of risk management. And this is just the set of problems for one service, right? So the one decentralized service that we're describing here is a decentralized Oracle network that provides data. Right now, there are hundreds of these decentralized Oracle networks providing distinct pieces of data, and they're securing tens of billions of dollars in value. And in my opinion, they'll probably be securing hundreds of billions of dollars in value once DeFi gets even a moderate portion of the value in cryptocurrencies to flow into it. The portion of value in DeFi right now being below 100 billion is kind of laughable when you look at the amount of value in the crypto format that could be in DeFi. And if these networks continue to secure anywhere from 60 to 80%, then you see the importance of maintaining their security and reliability, uptime, decentralization, and so on. This body of work has its own discrete problems, right? It's assessing data quality, creating proofs about the origin of the data, creating a consensus around validating the data, providing crypto economic guarantees that the network will deliver the data once it's computed it, and then ideally adding a layer of data privacy so that you can deliver data that's of greater and greater value while allowing it to remain private. Because what we notice is there's a lot of data that can be public, but there's probably even more data that's private, and the ability to maintain its privacy is quite important for the people that originate the data. And therefore, if you want identity data, if you want various advanced financial data, you need to generate some level of privacy, which once again, we're very happy to be building out Deco at the moment, which will generate the ability to prove things about data on chain without actually disclosing the data, which will meet people's requirements for delivering the data onto a blockchain in a way that they haven't previously been met. There's also problems around data aggregation and scoring and various data algorithm aggregation methodologies. So far, our systems have been immune to flash loan attacks, immune to various manipulations of that type because of the methodology we use to aggregate data. So far that is going well, but that's another area of research that we're consistently focused on and putting significant effort into. Beyond that, you have other types of data with their own distinct kind of research priorities and research challenges. One of those is insurance and climate data. We already power certain insurance and climate data applications. Those are problems partly, once again, around data privacy, partly around getting access to the data with other kind of IoT standards and getting signatures for the data into the consensus method, and then proving that the signatures were aggregated correctly from the origin, and a number of other challenges. And so that's another set of problems around kind of more esoteric, less easy to access data. Beyond that, we also have something called proof of reserves. Proof of reserves, I think, is something that's going to go very far because we see a multitude of different stablecoins and various asset wrapping initiatives that seek to bring assets on chain. And what proof of reserves does is it queries various APIs at a bank account or at a gold vault or at any number of other places to prove that an asset is actually somewhere off-chain, bridging the off-chain world into the on-chain world. And the challenges here are, once again, getting access to the data, making sure there's some privacy dimension for certain properties of the data when that's necessary, consensus, and also actually creating creative solutions to prove that the value of certain off-chain things is still there in order to back their on-chain counterparts. And so proof of reserves really becomes kind of a gateway for the off-chain world to make its way on-chain. Beyond that, there's also the world of computation, right? So there's data validation as one distinct set of services and research problems, and then there's off-chain computation as another distinct set of services and research problems. Random number generation through something called VRF is a very widely used service right now in gaming. It's very widely adopted on Polygon and various other chains where gaming is doing very well. It basically provides an on-chain proof that the data, that the random number was generated fairly and in a tamper-proof way, which is obviously important for many games. Beyond that, there's keepers, which is basically a form of trust minimized automation. These systems do things like tell the contract what time it is, tell the contract what to do, monitor other contracts to tell the smart contract what to do. All of these kind of advanced capabilities are possible when you have keepers because you have off-chain computation that's trust minimized. There's a number of consensus issues here, and really keepers is the beginning of more and more advanced off-chain computation within the Chainlink network, such that you could issue all kinds of commands from the keeper into the contract, and you actually see a choice about how much of the computation you want to put on-chain versus off-chain. The reason you would put some of it off-chain would be either because the on-chain environment can't do the computation, because the cost of doing it on-chain is too much, or because you want to maintain certain levels of privacy for the off-chain computation, right? And so keepers is the beginning of more and more advanced off-chain computation within the Chainlink network. It's now in open mainnet beta, but it's going out into full mainnet very soon. Beyond that, there's a multitude of different computation based services that I think smart contracts and hybrid smart contracts need, not the least of which is something like fair sequencing services. So I'm sure many of you are familiar with minor extractable value. Minor extractable value is a fascinating fundamental problem to blockchains that go to the core of the trust assumptions that users have and the fairness assumptions that blockchains claim to deliver on. And so there's there's a lot of debate and a lot of very thoughtful people doing a lot of very thoughtful work on how to combat minor extractable value. I think the early approaches have successfully lowered gas costs, but subsequent approaches, I think, will begin to focus more and more on conceptions of fairness, while still being efficient and creating an efficient market. Where all of this will end up, I don't exactly know, because it's an extremely complicated problem. But minor extractable value, fair approaches to sequencing transactions, transaction ordering is another area of research we're very active in, and we're working on solutions that can provide a fair approach. Once again, backed by the decentralized Oracle network, its consensus methods, and so on, right? So this is another example of a distinct service that would be able to order transactions fairly, generate additional usefulness and additional value for the hybrid smart contract, making it useful to users. Generally speaking, if you're interested in working with us on this research, I definitely invite you to contact us at research@Chainlink Labs. We have an internship program. We have a fellowship program. We have a lot of very smart researchers working with us, like Ari Jules as our chief scientist. We have Christian Kashan from the University of Bern. We have a lot of really smart and great other collaborators that are very, very thoughtful people. We take all of these problems very seriously, and very importantly, we don't just do research. We take the research that's done by these amazing people together with some of the people at IC3, and we actually turn it into a useful service that begins to power entirely new categories of smart contracts, basically making them possible, right? And so we are not just about generating research, we are about taking research and turning it into these decentralized services, pretty much almost always in this decentralized Oracle network format, in order to generate more and more advanced, more and more useful hybrid smart contracts. Another interesting resource that I recommend to everybody is smartcontractresearch.org, the Smart Contract Research Forum. It's a great place to go discuss these topics with other smart people. We consistently post certain research there, and we consistently try to discuss things there. It's a great place that we've been involved in and want to highly recommend for thoughtful discussions about the nature of these problems. It's impartial and focused on solving these research problems, or bringing really industry participants and researchers together to solve these problems. Other than that, if you'd like to join our team generally, we're very excited to work with you. We have a large and growing team that's completely remote, and that is open to working with people from all lines of research and really research engineering as well. Feel free to contact us. We're very excited to work with people that find these problems interesting and worthwhile. We think they're very important and worthwhile. Final point is there's a conference coming up, SmartCon, Smart Contract Summit. That's going to be a very well-attended conference. There's going to be a lot of speakers. There's going to be a distinct research track with a lot of innovative, interesting topics about both the markets-related side of things like CBDCs and the other things connected to actual original research. We'd be thrilled to have people attend, leave comments, tell us how we can improve the event and any of the research going on there. But beyond that, I'm just thrilled to to see any of you there and chat with any of you there. So that's the high level of the research problems we're working on, and kind of how that's going to probably evolve into a critical set of resources. We're excited to work with all of you as much as possible, and I think we might have 1 or 2 minutes for some final questions.
Yeah, we do have time for questions. Anybody have any questions in the audience? Anybody?
I wanted to speak up. So I wanted to ask, what kind of computation to actually envisage off-chain that's driven by privacy considerations? So not data focused, but actually something that's an interesting computation. What are your thoughts on that?
Oh, that's a good question, Ben. We should talk more. We see a lot of things. Like, we work with both crypto startups and fintechs and insurtechs and enterprises. So we actually see the spectrum, right? We see the crypto startups, we see fintechs, insurtechs at a couple of hundred people, couple of thousand people. And then we see like real big enterprises in the tens of thousands of people. Usually as the contract values increase, the need for privacy increases, basically. That's the fundamental dynamic that I'm noticing. And it's not even necessarily like a choice. Like, some of it in some industries is mandated from a legal point of view. Like, for example, in the trade finance industry, you are actually not allowed to disclose certain trade finance details, because people can reverse engineer how many chips will be generated based on the amount of chemicals arriving at a certain port. And then that information is not supposed to leave, right? It's not supposed to be available to anybody as a legal condition, generally from like various regulatory and other frameworks. So at the end of the day, I see a very, very large percentage of computation requiring privacy. I am actually fine with that privacy being achieved on-chain or off-chain. Just to be very clear, I'm not necessarily saying that more computation has to go into the off-chain DON network. The distinct benefits of that are that each service is a distinct network, right? So it's a distinct committee with its distinct goal, its distinct security, assumptions that can scale, and has one goal. It's a service. It's basically a singular service. And so in that sense, the ability to both maintain privacy by choosing the committee, and the ability to limit the amount of nodes that would have access to the data is very improved from putting the data into a general system, right? But I do think there will be general systems that do achieve levels of privacy. I don't know exactly how. It's unbelievably complicated. For years, I was hoping homomorphic encryption would be a solution, but unfortunately, that is not yet a solution. Beyond that, zero knowledge proofs doing interesting things, but that's also not. That's more off-chain, actually. That's more an off-chain version of the world. And I generally find it to be a big category of concern as you go towards fintechs, enterprise, and more value. So that's what I see. I think there will be actually an interesting mix where there will be certain things that people very aggressively want to make public because they want to create assurances for counterparties and even for legal reasons. And then there will be a distinct category of things that they have to keep private. And there will have to be a solution for that, whether that's on-chain encrypted code or whether that's off-chain systems such as Oracle networks running trusted execution environments or some other thing that obfuscates the data in as much degree as possible.
So we actually have one in the chat as well, and it is, and the question is from Connor: what kind of civil resistance is used to actually restrict participation in each DOM? So, like, what does it take to be a participant?
Sure. So we have a reputation framework and a reputation system that's working on production right now. You can go to different interfaces to view it. One of them is market.link. One of them is reputation.link. So the fundamental model for what we do is the creation of on-chain data that proves the quality of distinct nodes. And then the nodes that have consistently committed to deliver data, committed to do computations, committed to generate random numbers, committed to do, whatever specific service they were supposed to provide as part of a committee, they commit to that, and then they deliver that on an immutable on-chain ledger of some kind, right? So we have a very different environment for achieving reputation than the web, right? The web is you have an intern, they left a review, everything has 5-star reviews, everything that doesn't have interns doesn't have 5-star reviews, right? Like that's not very good. That's why a lot of, the reviews on the web are not so good. So when I say the word reputation, I'm very cautious, and, I want to find a better word. But really, the on-chain reputation dynamic is much more powerful, right? Because it's immutable, it's very difficult to gain. You know what people committed to. They committed to latency, they committed to data quality, they committed to, signing, they committed to doing a lot of things. And then you can compare their on-chain activity, right? And so what you see already in the Chainlink network is a lot of really high quality nodes, and more revenue slowly migrating to higher and higher quality nodes. And so the model for that is that you prove things about your node, and on the basis of that proof, you are put in a committee. And you're not put in a committee by like, any one person. You're put in the committee on the basis of users, right? On the basis of users making decisions and saying, hey, I want you to be in a committee because, you have consistently, you delivered 10 million pieces of price data with 99 and 5 nines or 6 nines, reliability level. And also identity, I think, is an important dynamic because I think you do want that for certain higher value committees, but you also have the ability to have pseudonymous nodes within Chainlink. Really, you can just compose the committee that you want within Chainlink. You can compose a pseudonymous committee. You can compose an identity-based committee. But our point of view is that what you should be composing is committees that have a very good on-chain reputation for performance of the type of data and computation that you're seeking to get from them. So that's kind of how we view it.
Yeah, so we have a break now for half an hour. So we can continue the conversation in Gallatin if we want to. There's a link for it in the Zoom chat. So we can meet up there. We can answer questions. We can all sort of, as a group, talk about this. And let's thank Sergey one more time